Guys, I am tired. I'm filming these videos back to back to back. It's Sunday, the 26th right now, and I gotta get everything ready for this week. And yeah, I miss you guys so much. I miss you guys in person. Ugh, what can we do? What can we do? Okay. So the last topic that we're talking about this week is experimental versus theoretical probability. All right, so that's the title. We're on page 57, bottom right-hand corner, 57. Experimental versus theoretical probability. It might not be 4:30. It might not be April 30th for you. It might be. I know that's when I'm scheduling this video for you guys to watch. I think I was wrong on the date in the other one, but whatever. So, experimental versus theoretical. All right, we're still talking about probability. 7 SP 3.5 through 3.7. So what is the difference between experimental and theoretical probability? Okay, so let's say we flip a coin. Okay, what's the probability of flipping a heads? Well, there's a 50% chance. 1 out of 2, because there's 2 sides. What's the probability of flipping a tails? 1 out of 2, because there's 2 sides. So 50-50. So theoretically, okay, in theory, ideally, the probability is 50% heads, 50% tails, okay? Theoretically is what we expect to get. What we expect to get or to happen when we do an experiment. Okay, so all of the examples that we did this week for probability, they were all theoretical. Flipping a coin, probability of heads, 50%. Rolling the 6-sided die. Rolling a 2, 17%. Okay? Spinning the spinner. Picking the marble. Okay, those were all theoretically. We didn't actually do any experiment. That was just in theory, what do we expect to get? What's the chance? What's the probability that we expect? Okay? So today we're focusing on experimental probability. All right? If they don't specify, if they don't tell you which one, then you're typically talking about theoretical. It's what you expect. Experimental probability, it's what you actually get when you do the experiment. In class, we would have done experiments and we would have talked about theoretically versus experimental. Okay, so experimental, it's what we actually get. What we actually get from doing the experiment. Experimental probability, what we actually get from doing the experiment. So, let's go back to the example of flipping a coin. Example. Flipping a coin. So say we're flipping a coin, we're flipping a quarter. Okay? So, we're going to do theoretical. And we're going to do experimental. Okay, so flipping a coin, theoretical versus experimental. And feel free, if you have a coin at home, do it on your own, okay? And write down your own results. So, theoretical, in theory, okay, what do we find is the probability of flipping the coin and getting tails? Okay, well, remember, theoretical, this is what we expect to get. So, we expect probability of getting tails. So, the top number is how many sides is tails? 1 out of how many sides do we have? We have 2 sides. So we have a 1 out of 2. 1 divided by 2 is 0.5. Move the decimal 2 times to the right. It's a 50% chance. That's a 5, not a 6. So we have a 50% chance. We have a 1/2 chance, a 0.5 probability of doing this and getting tails. I got heads. That's what we expect to get. So if we did it 1,000 times, 500 of the times you get heads, 500 of the times you get tails. But experimentally, let's see what we get. Okay, I got heads, so I'm just going to put heads. Let's do it again. Tails. 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 It was heads, you couldn't see it. Heads. Tails. I'm going to do it one more time. Heads. So, experimentally, what was it? Probability of getting tails. Well, how many times did I flip and get tails? 1, 2, 3, 4, 5 times. How many times did I flip the coin total? How many outcomes did I have? 1, 2, 3, 4, 5, 6, 7, 8. 5 out of 8. Okay, what is that as a percentage? 5 out of 8. 5 divided by 8, 0.625. You can times it by 100 or move the decimal 2 times to the right. 62.5%. So, in theory, it would have been exactly even. When I did it 8 times, 4 of them would have been heads, 4 of them would have been tails. Half would have been heads, half would have been tails. But when I actually did the experiment, 5 times out of 8 I got tails, or 62.5% of the time. So, theoretical, what you expect to get. Experimental, what you actually get when you do the experiment. And just so you know, the more times you do the experiment, the more times you repeat it, okay? The more times you do it, the more accurate it's going to be, and the more close your experimental probability will get to the theoretical. So we only did this 8 times. If we did it like 500 times, we'd be pretty close to 50% chance, because eventually it would just keep repeating, and it would kind of level out to what you were supposed to get. That's just like when we do a random sample. You know, when you just draw like 3 girls or 3 people, it's not really fair. It's biased. The larger the sample, the better. So the more times you do the experiment, the more accurate it's going to be. Okay, so let's do 2 more experiments. Let's do 2 more examples. I'm feeling orange. Example. I hope this orange shows up actually. It does. Let me zoom in a little bit. Example. Alright, Pizza Hut. Alright, Miss Fry, she likes herself some Pizza Hut. Pizza's good. Pizza Hut, I love it. So, Pizza Hut made 21 cheese pizzas. Did I say 2 more examples? We're going to do a little bit more than that. 21 cheese pizzas, 14 veggie pizzas, 23 pepperoni, and 14 sausage pizzas. I stopped writing the word pizza every time just to save space. So, Pizza Hut made 21 cheese pizzas, 14 veggie pizzas, 23 pepperoni pizzas, and 14 sausage pizzas yesterday. Okay? Based on this data, based on this information, based on this data, we need to predict, we need to estimate. Let's come up with a reasonable estimate of the probability that the next pizza is going to be pepperoni. So, based on this, we're just doing experimental, okay? Because this is actually what they did yesterday. This isn't like, okay, every year we make this many pepperoni, this many cheese, where it's like tons of days. This is just an experiment. So let's just say, based on this, what is the probability that today they're going to make a pepperoni pizza? That the next one that they're going to make is going to be pepperoni, is what I meant. Well, it's just the same thing, except for you just need to know that this is the actual experiment. You still set it up the same way. How many of our pizzas are pepperoni that they made yesterday? How many are pepperoni? 23 were pepperoni. So 23 were pepperoni. Over how many pizzas total? Okay? A lot of times people will put like 1, because they're making 1 pizza out of 23 that were pepperoni. No, that is not correct. The top number is favorable outcomes. Pepperoni. How many pizzas that they made were pepperoni? 23. Out of how many pizzas total did they make? Well, they made 21 cheese pizzas. They made 14 veggie pizzas. They made 23 pepperoni pizzas. And they made 14 sausage pizzas. How many total? Total means add. 1 plus 4 is 5. Plus 6. 1 plus 4 is 5. Plus 3 more. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12, carry the 1. 1, 2, 3, 4, 5, 6, 7. They made 72 pizzas total yesterday. Out of those 72, 23 were pepperoni. So what's the probability that the next pizza they make is pepperoni? 23 out of 72. What if they said, put it as a decimal? Fraction to decimal, guys. Fraction to decimal divide. 23 divided by, fraction bar means divide, 72. 0. Let's just do it to 2 decimal places. So 3 is going to be 1 or 2. That 9 bumps this one up to a 2. So 0.32, which is the same as 32%. So there's a 32% chance, 0.32, 23 out of 72, that the next pizza is going to be pepperoni. Okay. What if it said, based on this data, based on this information about yesterday's pizza, what's a reasonable estimate of the probability, so probability, that the next pizza is not cheese. So it's not cheese. Well, how many of the pizzas were cheese? 21. 21 out of 72 pizzas were cheese. 21 of the 72 pizzas were cheese. So how many were not cheese? Well, you just subtract. If we have 72 pizzas total and 21 of them are cheese, how many are not cheese? 2 minus 1 is 1. 7 minus 2 is 5. 51 of them are not cheese. 51 out of the 72 pizzas total. So the probability of not cheese, it's 51 are not cheese out of 72 pizzas total. 51 out of 72. Okay, so sometimes they're going to give you it as a word problem. Sometimes they're going to give you a table. So the next example, we're going to do a table. Okay, so in this example, we have a table. We have 3, 7, 2, 0, 5, 0, 6. And then 3. So, this is our table, okay? They could have put bars through it like this. If you want to, if that, whatever, it doesn't matter. Anyway, I recorded 1, 2, 3, 4, 5, 6, 7, 8 on 8 different days how many gators I saw in the pond behind where I live. Okay? One day I saw 3. The next day I saw 7. Then I saw 2. Then I didn't see any. Then I saw 5. Then I saw 0. The next day I saw 6. And then today I saw 3. Okay? Based on this data, what's a reasonable estimate of the probability? So we need to estimate. We need to predict. What's the probability that tomorrow I'm going to see more than 3 gators? More than 3 gators. So pause the video and try to make this prediction. What's the probability as a fraction that I'm going to see more than 3 gators? Okay. Well, how many times did I see more than 3 gators? How many of these numbers are more than 3? Is 3 more than 3? No. More than 3. 7, 5, 6. So 3 of these days I saw more than 3 gators out of 1, 2, 3, 4, 5, 6, 7, 8. So 3 out of 8 days I saw more than 3 gators. Okay, what if they said represent it as a decimal? How would we do that? Decimal, fraction to decimal, divide. 3 divided by 8, 0.375. What about as a percent? Move the decimal 2 times to the right, or times it by 100. 37.5. There's a 37.5% chance that I'm going to see more than 3 gators. Okay? What if it said, what's the probability of seeing a gator? I don't care if it's 1 gator. I don't care if it's 19 gators. What's the probability of seeing a gator? Well, how many days did I see at least 1 gator? How many days did I actually see gators? 1, 2, 3, 4, 5, 6. So on 6 of the days, I saw gators. I didn't see a gator these 2 days. So 6 out of the 8 days. Okay, both of these can be divided by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. So 6 out of 8 days, 3/4 of the time. I know that 3 out of 4 quarters is 75 cents. So 3 divided by 4. 0.75, or times it by 100, 75%. So although there's only about 37-38% chance of seeing more than 3 gators, there's a 75% chance. So it's really likely that I'm going to at least see 1 gator. All right, our last two examples are quick. I'm just gonna review it if we have a histogram or a dot plot. So here we have number of points and number of games. And we want to know what is the probability of scoring 30 or more points. So 30 plus points. Well, I see 0 to 9 points was 2 days. I scored 10 to 19 points for 4 of the games. How many games did I score 20 to 29 points? 5 of the games. What about 30 to 39? 3 of the games. 40 to 49? 2 of the games. Okay, so what's the probability of scoring 30 or more points? So, how many games did I score 30 or more points? So, right here to the right, because that's 30 to 39 points, and that's 40 to 49 points. So, 3 games, I was in the 30s, and 2 points, I was in the 40s. 3 plus 2 is 5. So, 5 of the games, I scored 30 points or higher. Out of how many games total? 2 plus 4 plus 5 plus 3 plus 2. We have to add up the bars to find out our total. 2 plus 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 5 out of 16 games, we scored 30 or more points. 5 out of 16. They might give you a dot plot, okay? Number of vitamins, all right? So, on this day, I took 1 vitamin. I took 6 vitamins on 3 different days. Oh, that's a lot. One day I even took 9 vitamins. This is an interesting one. All right, so what's the probability of taking what's the probability of taking, let's say, 7 or more vitamins? No, 7 or less. 7 or less vitamins. So this is our last example. So try to do this one. Really, guys, try. Even if you're wrong, it's okay. If someone texts me that they actually did this on their own, I'm going to be so proud of you. What's the probability that I ate 7 or less vitamins? 7 or less. Well, how many different days did I have 7 or less? So it's including 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. On 10 days, I had 7 or less vitamins. Out of how many days total did we record? How many days total were there here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 10 out of 11 days. 10 out of divided by 11. Whoa. 0. If we round to 2 decimal places, that 9 rounds it up. So that's 91%. There's a 91% chance. 91. That's like basically certain that I took 7 or less vitamins. Wow. Sorry, I lost my train of thought. So basically, so what's important to know from this video? Experimental, it's actually, you take it, you record real life, and then you predict the probability. You record real life. You actually do the experiment, and then you predict, okay, on the next day, what's the probability that I'm going to take 7 or less vitamins? Or, all right, out of this experiment, how many times did I actually take 7 or less vitamins? Theoretical, it's just what we expect to get. So that wraps up this week on probability. If you guys watch these, you guys are awesome. This is not easy stuff. I'm so proud of you. I miss you. I love you. I mean it. Bye.